All right. Now that we have seen the idea of a limit, now we can learn how to find the derivative of using first principle. So when we use first principle, we need to remember that we are using this formula. So this formula is given on your formula sheet. You don't have to worry much about memorizing this formula, but you need to understand how to use this formula and how to substitute your given equation or function, right? So if you look at the question here, 8.1, they ask you to determine the derivative from first principle if f of x equals to 2 minus 3x squared, right? So how can we estimate the derivative using the first principle? Okay, as I said, we use this formula. So the formula as it is, we just substitute what we are required to find. Okay, so here f of x plus 8. So in the place of f of x, because we have f of x here, in the place of f of x, you just put x plus 8, right? So you have f of x equal to 2 minus 3. So in the place of x here on f of x, you just put x plus h, x plus h. Okay, and then you square this, and then minus in the place of f of x, right? You have f of x, which equals to this, right? So it equals to 2 minus 3x squared, right? So you have your f of x equals to 2 minus 3x squared. So you just write it as it is. So you divide, you need to always remember how to divide, right? So you divide by h, right? Okay, and then the next thing, you can try to tidy this up, right? So you can see if there's things that you can cancel or things that you can add. So let's tidy this up. So you have 2 minus, so this we can expand, right? Which is x squared plus 2xh plus h squared, and then minus, so we can have minus 2 when we multiply with a negative, and then plus 3x squared when we multiply the negative with negative 3x squared. And always, we should always remember to divide by h. So h tend to 0. So we keep on writing lim h tend to 0. As you've seen from the idea of a limit, you only stop writing the limit when you substitute your h to 0, right? So we can still, okay, so this is negative 3x squared, and then you have negative 6xh, and then you have negative 3 h squared. So we're just distributing this negative 3 on this uh, um, expression here, okay? So we have what? Minus 2, and then plus 3x squared, and then we divide by h. So we can see in our numerator, we do have like terms. So the like term that we can see here is negative 3x squared, this one here, and also this one here, which is positive 3x squared. So they can cancel because it's negative 3 and positive 3, so they cancel. And then the other one that we have, right, it's we have 2 here and also negative 2 here, so these will cancel, right? So we can clearly see now we'll be left with, okay, so lim, we write this, okay. So we'll be left with minus 6xh and then minus 3h squared. So divided by h. So we write that. Okay, and then we write lim h tend to 0. Remember, we have been substituted our h. So we write this. So when we take out, because we do have a common factor here, we can take out a common factor. So when we take out a common factor of h, right, we are left with minus 6 x minus 3 h, right? So divided by h, right? So we can clearly see that the h can cancel here, and then we can just substitute our value for h, right? So if we substitute our value of h here, our final answer will be minus 6x, because the h here is 0, so it's minus h2 times 0, which is 0. So your final answer will be minus x. So you can always test this out, right? When you find the derivative here, right, you can clearly see that the derivative of this, right, it's what derivative of 2 is, it's a constant, it will be 0, and then the derivative for minus 3x squared is minus 6x. So we can clearly confirm that this is the correct answer. All right, so the next example here, we have f of x equals to minus 2x squared plus 3x. So again, we are determining the derivative using the first principle. So when we use the first principle, we need to remember that we are applying this formula, or we are using this formula which is given on our formula sheet, so we can just write it as it is. So in the place of x, we just put x plus h, okay, here, and then you have your f of x, right, divided by h. So we can use this formula. So it will be lim h tend to 0, and then f. So in the place of x here, we can just put x plus h. So we have minus 2 in the place of x, x plus h, and then we need to remember that we need to square it, and then plus 3x. In the place of x, we need to remember that we need to put x plus h, right? So for this one, and then minus f of x, we are given f of x, which is minus 2x squared plus 3x, okay? And then we divide everything by h. Please don't forget to divide by h every time. So we have lim h tend to 0. So if we can see, we can expand this. Okay, so if we expand this, we'll have x squared plus 2xh plus h squared, and then we have plus 3x plus 3h when we expand this. So this negative here can also multiply here. So we have minus, in this case, we'll be having plus because it's minus and a minus, so it's plus 2x squared. And then the negative also has to multiply here as well. So you'll have minus 3x, okay? And then again, we divide by h, okay? Okay, next step. So we have lim again, h tends to 0. So what do we have? We have, we can distribute your negative 2 here. So we'll have negative 2x squared, and then minus 4xh, and then minus 2h squared, and then we just have our 3x plus 3h plus 2x squared minus 3x, and then again we divide by 8. So the next step that we do here is to tidy this up again, and then group the like terms. If we have, let's see, we see that we have minus 2x squared here, and also we have what, plus 2x squared. So this can go, right? Which other like terms do we have? We also have 3x here, and then minus 3x here. These can go as well. So do we have any like terms? If we see here, we no longer have like terms, so we can just write what's remaining just to tidy this up. Okay, so we have minus 4xh minus 2h squared, and then plus 3h, all divided by h. Okay, so we need to remember that we need to always write the lim h tend to 0 before we substitute our h which tends to 0. Okay, so we can take the common factor out. We do have a common factor which is h, so let's take the h out, and then minus 4x, right? That's what we'll be left with on our first term here, or expression here. So the next one will have minus 2h, and then the other one will have 3, just 3 when we take out h, right? So we need to divide by h all the time. So we can clearly see that the h can go because it can cancel there. And then now we apply our limit. So our h has to tend to 0. So if our h tends to 0, we'll have minus 4x minus 2, our h tend to 0, and then plus 3, right? So our final answer will be minus 4x plus 3, right? So this is our final answer. So again, we can always check this out as well. If we apply the derivative here, okay, so the derivative for the first variable here, which is minus 2x squared, so it will be what? It will be minus 4x, right? Because the 2 is just minus 1. Okay, so it's minus 4x, and then plus 3. The derivative for plus 3 is just what? It's just 3. So this is your derivative. So you can clearly see that it's the same as what we have found using the first principle. Okay.